In this video, we want to spend a little bit of time discussing some of the basic principles of GIS. So in this video, we're not going to actually get into the actual mapping of how we actually put things onto a map. We'll do that in a separate video. But in this video, what we want to do first is just talk about some basic understandings and basic topics and things for you with GIS. If you've never used Google Earth, we strongly suggest that you download Google Earth and try Google Earth and see what it does. It's one of the best little free tools out there. And we've given you a link on where to go get Google Earth and things. So strongly suggest you try that. The Earth is a ball. But yet we try to take this ball and represent it on a flat surface. Well, we have two things that we need to be able to do with this ball. We need a coordinate system on this ball, and we also need how do we project that ball into a flat piece of paper. So the coordinate system, if we're on a flat sheet of paper, we're used to an XY coordinate system, what we might call a Cartesian coordinate system. We're used to that XY coordinate system. Normally on the Earth we use what's known as latitude and longitude, but that's only just one type of coordinate system that we might use. Lines of longitude run perpendicular to the equator and they're measured east and west from the prime meridian. Lines of latitude run parallel to the equator and they're measured north and south of the equator. So we have that system. But we could use just a system of X miles and Y miles from a given point. And that is also used as a coordinate system. So when we look at our data, we have to have our data in a coordinate system so we can project it on a map and lay one layer on top of another layer on top of another layer on top of another layer. So we need to have a coordinate system that makes sense and aligns. And there's lots of different coordinate systems out there, and we will use several of those coordinate systems in this class. So we have to understand we have to have a coordinate system. We also have to have a projection. So how do you take that ball and project it on that flat surface? Well, there's lots of different ways to do it. You might use a cone and then unroll that cone, or you might use a cylinder and unroll the cylinder to get a flat surface. But there's lots of different ways we can get this projected globe, nearly a sphere but not really exactly a sphere, onto a flat surface. And so that's what we talk about when we talk about projections. So our data has to all be in the same projection as well in the same coordinate system for everything to work right. Now you'll find that the software can do coordinate changes. So if you have one coordinate system and you tell it what that coordinate system is and you have another coordinate system for this data, it can change one data's coordinate system into another data's coordinate system. So we can do these changes of coordinate system, and we can do changes of projections also. But we have to know how the data is being projected and in what coordinate system that data is being used in. So coordinate systems and projections are critical. We will not do a lot about coordinate systems and projections in this class, but we need to be able to understand that they exist and that we have to be aware of them. But we will do a little bit with coordinate systems and projections, but really the more in-depth coordinate systems and projection stuff will be saved for a more advanced class than this class. The software we'll use is known as ArcMap. Now there's three different versions of ArcMap. There's ArcView, ArcInfo, and ArcEditor. And each of those have slightly different features, but the interface looks the same. And so since the interface looks the same, we'll refer to most things as ArcMap. It's a product of a company known as ESRI. And we'll be using this ESRI software, which is one of the key softwares used in the GIS field in the real world out in industry. We'll be using ArcMap as our keyword. We won't worry which version you're using, because everything that we'll do can work in any of the versions and things. We need to understand the data set. So when we look at data sets, the data set can come in varying different fashions. So for example, we can have line data, a polygon, we can have point data, or we can have a picture. So we have these different types of data. And in general, we want to make sure that our layering of our data is appropriate, so that we make sure that on the bottom is opaque layers and on the top is either transparent layers or layers that aren't filled. So in data, we put point data at the highest level. Point data represents individual points, like on a world map might be cities. Now on a blown up map, when you get down into the detail, you wouldn't use a point to represent a city. You'd actually have boundaries of that city. It might represent a person's home or a piece of property. So lots of different things you can use for point data, but point data is at the highest level. Underneath point data, we then put line data. Line data might be a road or a river or a stream. And again, depends on what the magnification of that map is. Is that a polygon or is that just a line? If it's a line, we can change the width of the line that appears on the map, but the line actually has no thickness. The change of width is one of these things that we're just doing to make it more observable, but that width does not correspond to the actual width of the stream, for example, if it is in line data. But the length does correspond to the length of the stream. So we have point, line, and then we have polygon data. A polygon is any closed surface. Anything that we can fill with a color would be a polygon. We can also change what is the outside boundary of that polygon, what does it look like. We can do some of those type of things, but a polygon is a closed surface in that we can fill it with a different color. So we can have different boundary types. A polygon might be a county, could be a city, could be a river like the Ohio River. We might make into a polygon, but it is about a mile wide at the Louisville, Kentucky area where I'm from, and so we might make that into a polygon to actually show that width and things there. Census tracts, zip codes are all polygon data. They're actually closed surfaces. Underneath that, we then would put things like pictures. So an orthographic picture, an airplane flies over an area, takes photographs of the ground. We take those pictures, we might lay them down at the lowest level, and then we would have our polygons, our lines, and finally our points on top of that. There are reasons sometimes that you do not always keep it in that order, but in general that's the order in which we work. We also have project files that we'll create. So when we're in the ArcMap software, we will save the project that we're working on. And that project will have multiple layers or multiple shape files in it, as well as it could have a raster file, which would be a picture inside that project. When we save that project works as a pointer. So it's saying, go get this point data over here where it's stored on the computer, get this line data over here where it's stored on the computer, get this picture over here where it's stored on the computer. So it actually does not bring all that data in, but when it saves the information, it actually saves where that data is located. Instead of actually bringing it in and making that project file huge, it keeps it in where they were originally saved and only puts modifications into what's being saved. So for example, if I have a river, I will tell it that that river is going to be blue because the line file will not have a color associated necessarily with it. It will say that line file is going to be blue. Well, that blue would be saved in the project data. The actual length of the line would be saved as the line file that we brought into the project. So you got to be very careful not to move the data once you create a project. So if I've got all this data and I decide to move all this data over to my portable hard drive, my external hard drive, and take it off the hard drive of my computer, then when I call it my project, it will not know where the data is because you moved the data, and since it's been moved, it doesn't know where it was moved to, and thus we have a problem. So you need to store your data where it's going to be kept before you start your project. Once you start your project, if data is moved, then it'll have a broken link, and we'll have to go reassociate that broken length with the actual length. That's one of the reasons that using a website or an internet site where you can actually put the URL in is very key, because if you move the project file to another computer, that URL is still constant, it didn't change, and you can go back and the data will automatically be there and things. So project files do not contain the data, they only contain references to the data and change the color and change the fill and things like that. Data storage is also critical. As we said, we don't want to move the data once we put it someplace, but we also got to be able to find the data that we have. So building a hierarchical nature of data is important. And the way that I've done this is I've built it off of geography. So we start with the world, and under the world we have countries of the world. So for example, we'd have the United States under there. And then under the United States we would have states, because that's the next political division. We might have some regions of the country too that we'd look at, but we'd have states. And under these states we'd have all the states of the United States listed. And under each state we would have the counties. And under counties of that state, we'd have all the counties of that state. And then we need to sort of associate our data in some fashion. And so what we'd have is maybe point data under counties, and line data under counties, and polygon data under counties. And we also might have raster data, bitmaps under counties. And finally, we might have an area where we have our compressed files, the files that we went out on the internet and found and brought into our computer to use. We might keep those just in case we would destroy the original file by accident in building a map. We might want to be able to go back and have the original file, so we might keep all the compressed files, which we say come in a zip format. That's a typical terminology that's used. It means it's a compressed format so that we can bring in multiple files together. But when we talk about these shape files, when I look at a point shape file, on my hard drive, it's not one file, but it's multiple files. And we need to keep all those files together in the same subdirectory. And so that's why when we transport those files from one computer to another computer, we want to make sure that we keep them together. So we zip them sometimes, we compress them all together into one file. So you're only moving one file from computer to computer instead of moving multiple files there. So we do keep these compressed files. So building a data tree, a data structure is important. Now, I didn't go out on my data tree and populate it with every country in the world, or with every state in the United States, or every county in a single state. I populate it as I need it. But once I have this structure, it's easy to populate later. Data can be added to a map in 3 different fashions. If you're working in a Windows environment, then you can do just a simple drag and drop, drag the file, the shape file, the SHP file, over and drop it on your map. And it will appear on that map. You can also add data by using the diamond signal with the plus sign in it, and that is the Add Data button within ArcMap. Or you could be using a program known as ArcCatalog and have the ArcCatalog open, which is a lot like Explorer, but you click on the file and you drag it over and then drop it into the map from ArcCatalog. Now ArcCatalog has a lot more functions than just dragging data out of it, because if it only had those functions, then we might as well use Explorer, which is built into Windows. Now this software is only designed to work on a Windows-based machine, directly being installed on the machine, but through some internet ways you can run it on Mac also. As I mentioned, ArcCatalog looks very similar to Explorer, but it also gives me the ability to make geodatabases. It gives me the ability to make layer files that actually have colors and symbolism built into them. So when you bring in that layer file, it already has a symbolism built into it that you don't have to go back and say that rivers are blue and roads are black, or the different types of interstates versus county roads have different shapes and things. That can already be built into a layer file. You can build, as I said, geodatabases, layer files. You can start a new shape file from scratch. So if you want to do some digitalization and take a photograph and actually digitize the photograph and get some things off that photograph into line files or into polygon files or whatever you need to, you can do that all in ArcCatalog. So ArcCatalog is a very good feature. It's a program that actually will run either independently or within ArcMap. One of the key things that you must do with data is that you must be able to go into the data and change its properties. By changing its properties would be changing the color of a fill, creating a gradation for different layers within that fill. So red might represent a certain income level, and green represents a different income level, and yellow would represent a different income level. Our river needs to be changed from purple to blue. You want to put a boundary that looks like a state boundary around the edge of the state and put a different boundary that looks like a county boundary around the county. You can also do querying of data, and you're going to do a lot of stuff in the property window. To get to the property window, you double click on the name of the shapefile, or you right click and go down to properties. Either way, it gets you to the property window. And probably the thing that I use the most in the property window is symbology and next querying data. So those are the two big things that I use in the property window, and they're each tabs on the property window. So when you open up the property window, you'll see multiple tabs across there, and you can select whichever tab, and then there'll be multiple things that you can do within that tab. When you create a final map, you need to be able to label that map so we know what's going on. So if I'm not the person creating that map, I can look at that map and understand what's going on with the map. You don't want to put too many labels onto the map, but if you put too many labels onto the map, what you're going to find happens is you can't see what the data is really telling you. You can also decide when to turn on a label and when to turn off a label because of how you zoom into that data. So it's very critical that you label things appropriately, not over-label things in your map, because if you over-label things in your map, then you cannot see the geography underneath the labels and things. So labeling is key. Remote sensing is a topic that's not going to be covered in this class, but is a topic that you could take a separate class in. But remote sensing is taking aerial or satellite information and taking that information and making it into an organized set of data that can be used. So for example, you might be flying with an airplane over a cornfield and you want to find out if there's diseased crops. Well, those diseased crops have a certain signature that is different than the signature of healthy corn. Well, those colors are not in the visible wavelength, but they're actually in the infrared wavelengths, the near infrared wavelengths. And so by having the right camera with the right type of filters on it, we can see if that field has damaged crops or not. So we take a photograph of that field, we look for a certain wavelength of infrared radiation coming off that field, and we can plot actually where the damage is and where the damage is not. That's one example of using remote sensing. We have a worry about runoff of water on an area. So as an area becomes more commercialized, more residential from being farmland, we've got to worry about the impervious surfaces. And so we would like to be able to do that more automatically than have to actually go in there and physically look at it. So we get the data from an aircraft or a satellite, most likely an aircraft, and then we look for certain color signatures that tell us that there is impervious surfaces there. So remote sensing is its own field of study. It's important to know about, and if you're interested, we do have a class in remote sensing that you can take. Report creation is a critical factor also, because after you make your maps and you label them appropriately, you also have to create reports explaining what you learned by making the maps and things. Not what you learned on how to make the maps, but what did the data tell you about an area and things. So you must create reports. For our sake, we want our reports coming in a format of Microsoft Word. In the text, you can find different links to programs that are free that do Word type reporting, both in spreadsheet and in word processing, and you can then save them out in the standard formats of Excel or the standard format of Microsoft Word, a document format. So you can go out there and find this free software if you do not already own the software as you create the reports to turn in to us. In this module, we want to make sure that you can actually do some basic GIS. So we've given you a series of assignments and what we want you to do here, and those assignments will be turned into us not as full reports. The full reports will come with the case studies, but these will be turned in as just screen captures, that you captured a picture off the screen for us to look at and things. We want to make sure you can put data onto a map. So we'll have another video that will actually show you how to do that, but we want to make sure you can put data right onto a map. So that'll be a screen capture that will show us that you can put data onto a map. We want to make sure you can add an image to a map. And again, we'll have some links where you can find some images, and we want to make sure that you can put an image onto a map, and we'll again show you how to do this in another video. We want to make sure that you can create a basic report, use Word, Excel, and ArcGIS or ArcMap all together, so you'll turn in a very basic report to us. It won't have much writing on it. It'll basically make sure that you can capture things off the screen make it into a report, and so on. We want to make sure that you can do a data file structure that we talked about previously. So you're going to give us a screenshot of your computer showing us your data file structure. Want to make sure you can put labels onto a map. So you're going to give us a map as a screenshot with some labels on it. And we're just going to look to make sure you can do that and that you did not over-label the map and things. We want to also make sure that you can do some other basic techniques. So we will have an assessment that you'll do, a test if you will, at the end of this module to prove that you have those knowledge bases. Once you can prove that you have these knowledge bases, at that point you can do any one of the 6 modules that we have in any order that you want to do them. But we've got to make sure that you can do the basic GIS, very simple stuff to start with. We'll do much more complicated stuff in the case studies and the videos that are associated with those case studies. But we want to make sure that you can do some basic GIS, and that's the purpose of this module. At the end of this section, you'll also find that we've given you a glossary, and that glossary is with some key terms. That is going to be an evolving glossary, obviously, as more key terms are put into it. You'll see that it'll be longer and longer, and as appropriate, we will hyperlink out of the written text to the material in the glossary so you can look at definitions. We'll also eventually give you a bunch of hyperlinks in the glossary that you can go to other sources to read a little bit more about what we've given you as a definition. So in this module, we're going to get the basic principles of ArcMap down, understand some basic GIS and remote sensing as we've already talked about, that you can get a feel for what's going on in this field of study. And once you can prove that you have expertise in this area, then you can move into the case studies.